Okay, lesson 2.2. Defining the derivative of a function and using derivative notation. So previously we had done the derivative at a specific point for a curve. Now we're just going to generalize it for any point for any curve. So here's the general equation of the derivative. The general equation of the derivative. Is equal to so this is the general equation of the derivative, and it will equal to, basically it's the first definition I did without the a. It is really f prime at whatever input x, not a but x, f prime of x will equal to the limit as h approaches 0 of what? It was f of what? Instead of a plus h, we're going to have f of x plus h, where a is x, minus f of x over h. See, I'm not putting a in there. Let's go with x, okay, over h. This is the definition of the derivative at any point on a graph of a function. Provided, extremely important here, provided that the limit exists. It has to be the limit has to exist at that x value, or else then we have a problem. So that's very important, that, and I just said that that provided the limit exists is very important. Let's apply this concept now then, that we can find the derivative of a function at any point. And basically we're going to find the derivative formula for this particular third degree function, and we can just evaluate it at any point given that you could give me, and find the derivative. So let's go ahead and find the derivative function of this using this definition here. All right, let's do it. So f prime of x is going to equal to the limit as x approaches is h approaches 0 of f of x plus h. This is going to be so much algebra. I need to write small here. All right. So we're going to go f of x plus h. So for every input, for every x, this is where it gets confusing. For every x, for this situation, I am going to substitute it in, for every x, I'm going to substitute in x plus h. So it's kind of weird. It's like, how the heck is that true? So in the function here, for every x, I'm going to plug in x plus h. Let's do that. Okay, so there it is. X is x plus h. X is x plus h. Minus, here's another x. I'm going to plug in x plus h. All right. Minus, we're going to go to the second part here. Minus f of x. Well, good. Well, this is easier now. This is f of x, because f of x is this. Put it in parentheses. It's just algebra. This is just so much algebra. Over h. We're good. Good so far. This right here is we need to expand this x plus h to the third. Let's do that. I'm gonna do that on the side over here, because that's just algebra. X plus h to the third means x plus h times another x plus h times another x plus h. Okay? We need to multiply that out, expand it. Let's do that. Now let me do the second ones. Let me do these ones first. X times x, x squared, hx, x times x, and then another hx, and another h squared. That, and then we multiply times x plus h. We got our plus h, x squared plus 2hx plus h squared. We're going to do this, multiply this now again. X times x squared is x to the third plus 2x squared h. This is going to be plus h squared x. Okay. All right. Maybe I need to be a little more. This is going to be h times x squared. That's different. That's going to be plus h to x squared. Then we got 2h squared x. 2h squared x. I can put this one here, 2h squared x, because like terms with this. Then this is going to be h to the third. All right. So now let's combine things here. We got x to the third plus this can combine with this one here. Yep. So we're going to write down 3x squared h. These two here can combine to be 3h squared x. And this could be h to the third. So you just got to be extremely careful with this algebra part. All right, let's go back over here. So we got this f prime of x is going to equal to the limit as h approaches 0 of x to the third. Let me bring that over there, that over down, plus 3x squared h plus 3h squared x plus h to the third. And now we can go ahead and distribute this in here. That would be minus x minus h. Distribute this over here. Yeah. So this is going to be minus x to the third, and negative times the negative is a positive x over h. Let's continue. F prime at x is going to equal to the limit as h approaches 0. Okay, there's a lot of things that are going to cancel out here, and that's what always happens with these. X cubed minus x cubed cancel out. What else? Negative x and positive x cancel out. Let's see, anything else? Anything else? Positive h, you see that right here. Positive is let's see. No. That's it. I think that would be it. Let's go ahead and just continue on then. We got what now? 3x squared h plus 3h squared x plus h to the third minus 1 over h. That's what we have now. That's all we can do. Other, let me see, minus h. Minus h. It's minus h. All right. So what can we do now? We can factor out an h maybe at the top. So let's go ahead and continue on. That this is going to be f prime at x is going to equal to the limit as h approaches 0 of, let's factor out an h at the top. Then we're going to have 3x squared, okay, 3x squared plus 3hx plus h squared minus 1 over h. Ooh, now we can cancel out the h's. Yes, now we can cancel out an h with an h. So now we're going to have the limit as h approaches 0 of 3x squared plus 3hx plus h squared minus 1. And now we can go ahead and substitute h is 0. If h is 0, this cancels out here. Because h is 0, this part cancels out. H is 0, this cancels out. And then we're left off with 3x squared minus 1. And this is the derivative of this function. So this is how everything works out to be. The derivative is 3x squared minus 1. Moving on to this. So what are other notations for the derivative? That was the derivative. We found the derivative. Other notations for for the derivative are, if we use the traditional notation, y is equal to f of x to indicate that y is a function of x, or that the independent variable is x and the dependent variable is y, we can denote the derivative in several ways. F prime of x, that is the derivative. And that is also equivalent to saying y prime, the derivative. Y prime is the derivative. Dy dx is the derivative. This is called Leibniz notation. Df dx. Basically, the ones you need to know are these three. The other ones, just kind of be familiar with. D dx of f of x. That's another notation that's been written. This d capitalized f of x. These are getting kind of like, you never really see these. I think these are like outdated. Dx f of x, I don't know. The first three are the ones. So for f of x, for the previous problem we did, for f of x equals x to the third minus x in the previous problem, the derivative can be denoted as f prime of x equals 3x squared minus 1. Y prime is equal to 3x squared minus 1. Dy dx is equal to 3x squared minus 1. And really, I should just stop here. All right, same. They're all the same. They all represent the same thing, the derivative. Let's finish off with problem number 2. A word problem. W is the amount of water measured in gallons in a bathtub. So this is the amount of water in a bathtub, W. T is the number of minutes since it was unplugged to drain out the water for the function W of T. What is the meaning of W of 10 equals 13 and W prime 7 equals negative 4.3 in the context of the problem? Write complete sentences. Okay. So you got a bathtub. And in there, what is the meaning of W of 10 equals 13? Where W is the amount of water in a bathtub. T is the number of minutes since it was unplugged to drain out. So this one is that at T equal to 13, no, T equal to 10, this input. At T equal to 10, there was 13 gallons of water in there. In the bathtub. Okay, so at T equal to 10, there was 13 gallons in there. This right here is saying that once it started, see, this is at T equal to 10 after, because it's talking about T is the number of minutes since it was unplugged. So at T equal to 10 minutes after it was unplugged, there was 13 gallons of water in the bathtub, more complete. Whereas this one here, it says that at T equal to 7, the rate of change of the water draining from the bathtub is 4.3. And negative is because it's draining, it's losing it. So this second one is a rate, whereas this is giving you an amount at a time, at any given time, which the time is 10. So let's do that. So how do you write down complete sentences? After 10 minutes, there is 13 gallons of water in the bathtub. For the second part, on the 7th minute, the rate of change, this is the water is draining at a rate of 4.3 gallons per minute. So the second one is the rate of change. The first one is how many gallons are at a time equal to 10. Problem 3. An equation of the tangent line to the graph of y equals f of x at the point where x equal to 2 is y equals 4x minus 5. So it says to find f of 2 and f prime of 2. Okay, so this is absolutely very important to understand, is that they're telling you that there's some function f of x. Whatever that f of x is, f of x could be any function. F of x could be a exponential function. F of x could be, we don't know what it is, a quadratic function, a radical function, a cube root function, whatever that function is. Okay, so whatever that function is, we don't know what that function is. But what we do know is this. Let's do a graph. Let's draw a graph here. This is x and this is y. So an equation of the tangent line to the graph of y equals f of x at the point where x equal to 2. X is equal to 2 is y equals 4x minus 5. So I'm just going to draw something. Let's actually, let me write down let me graph actually this tangent line. So it's going to be what? Negative 1, 2, 3, 4, 5, and it has a slope of up 4 over 1. So it's what? 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. It's just very rough. 1, 2, 3, 4 over 1. So I got this graph going something like that. And so maybe the graph is going to be whatever. Now, see, this is the tangent line. And maybe the other point of the actual function here, y equals f of x, maybe is this function. I don't know, I'm making up what it would be. Maybe it's an exponential or something. So here, at this point. So it's saying, what is f of 2? What is the function of 2? Find f of 2. Well, f of 2, what is f of 2? Well, don't they share the same output? Both this red line and the curve, whatever is this curve, we don't care about what the curve is, but we do have the line here. Just plug it into this to find the output, put it into the line, because they share the same output. So if you plug in x is 2 here, x is 2, then that'll give you 4 times 2 is 8, 8 minus 5 is 3. Easy, 3. F of 2 is 3. Okay? Yes, that's good. Okay, so now what would be the rate of change of f, whatever f is, at 2? Well, that's exactly what the point of this is. The point is that they share the tangent line at this point is the slope of the curve at this point. So what is the slope of the line? The slope of the line is the slope of the curve. Easy. The slope is 4, because that's slope mx plus b. So this is going to be 4. Easy. And we're done with this. So the tangent line to f of x at x equal to 2 is y equals 4x minus 5. Therefore, they share the same y value at that point of tangency. So therefore, f of 2 is going to be 3. And then f prime at 2 should be the slope of 4. And we're done. See you next time.